Good morning, everyone. And here I am there to give you a orientation introduction for the subject, namely Internet of Things, a practical approach. As you can see, it is a 202 approach where there will be 50-50 of lab and theory, where the lab is given more significant role actually, and the syllabus you can see. Okay, just the codes etc. we can ignore for the time being, and let us focus on the importance of the subject. The prerequisites is you should little bit know about the microprocessor and microcontroller, along with a little bit programming language like C or C++ or embedded C. Python, if you know, it is very better for the Raspberry Pi, which is not an mandatory one. Okay, the unit one comprising of embedded computing, little bit background we are taking here, introduction, then the microprocessor basics, fundas, and embedded system design process. Okay, and then the laboratory part, experimentation demonstration will be on the IoT device Arduino Uno or another version Nano and Mega. Okay, and the self study is kept as CPU power consumption. Okay, unit 2, little bit we move ahead, defining the IoT and designing IoT system, then IoT protocols. The earlier protocols themselves little bit modified so that the power consumption and Bluetooth or wireless communication technologies are taken into account and modified the protocols. The same thing holds good for the communication protocols, IoT levels, then templates, and again the experiment part is there. Every unit you can just see, every unit is having a part of experimental demonstration. 1 or 2 experiments in the first unit, 1 or 2 experiments in the second unit, like that. The unit 3 moves to the prototyping of the IoT, where we are making an experimental demonstration kit. Then examples are advantages and disadvantages are discussed. Then hardwares like sensors, wearable devices, and the related software, the related technology and protocol. Then we move to the domain specific IoTs, where the areas are home automation, automated cities, smart cities, environment, energy, retail marketing, logistics, agricultural and industry, along with the health and lifestyle. Okay, again we are having some experimental demonstration on the Arduino Uno. The unit 4 goes for the little bit higher end of the IoT, that is comprising of IoT architecture and protocols. Along with that, some experiments on Raspberry Pi and Orange Pi. Fifth and the last unit, cloud services, where the IoT gets connected with the cloud so that you can remotely work on the IoT. Again, there will be an experimental demonstration on Raspberry Pi. So this is all about the syllabus as such. Now let me go to the some introduction of IoT, a practical approach. IoT, a practical approach. Introduction. In the introduction, we are having how it has evolved, how it has been basics and fundas of the IoT, and the application and the future scope. This is the 3 parts we are going to little bit briefly study about that. Introduction. Today the IoT demand is very high. Everywhere we are using the IoT applications, and it is also having, you can say, just see the useful applications, very useful applications using the internet as well as the IoT devices. The definition of the IoT as such, you can just out of the interest I am just trying to tell you, IoT is a network. Okay, without network the IoT cannot work properly, in which all the physical objects are connected to the internet through the network devices or routers and exchange the data. Okay, for example, temperature sensor itself. Temperature sensor grabs the temperature from the local area and it sends to the destination via the internet. What are the advantages? It reduces the human effort and it can be done intelligently. Intelligently, I shall elaborate later, while you can introduce some AI components also. And autonomous control is another one. Autonomous control is that automatically, when the temperature rises above a threshold value, some automatic activity can be done. So that is the meaning of autonomous control. This is the internet IoT paradigm, where the globe is there, then agricultural indicated by this spot, then medical is indicated, this one healthcare indicated, then the fabrics. Okay, all right. The various devices of different fields with the internet, you can see over here the globe, then the audio systems, then fashion designing, then agriculture, you can say, then the drones, then smart wearable devices, then home automation, then various kinds of mobile handheld devices. Okay, then the gardening, various kind of things come into the picture of IoT. And the definition of things. What is the meaning of Internet of Things? Things. The word things is explained as it can be a hardware, it can be a software, it can be data, or it can be service also, connected to each other. This is the point to be noted. The things, how we defined hardware, software, data, and service, connected to each other and the internet. Okay, the devices are connected to each other and the internet. That is the meaning of things. Applications of the internet of things, where medical domain, if you look at that, remote health monitoring is one of the thing, then blood pressure monitoring, heart rate monitoring, sugar, and major changes of the body during the exercises and the tests. Transportation, if you look at the applications of the IoT, smart parking, traffic control, toll collection, vehicle control. Autonomous vehicles are coming nowadays, where they are becoming very popular along with the electrical cars, etc. The logistic management, the tracking, tracing, etc. Road safety, assisting the driver while driving in the highways or any road. Then the next field is the environmental monitoring, where accurate information of air quality is being can be displayed, water quality, soil conditions, and atmospheric changes. So these are the few applications of internet. Along with that, manufacturing also can be automated using the IoT for the sake of rapid manufacturing, real-time optimization, product manufacturing, and dynamic response of product demand. Particular product, if it is having a demand in a particular area at a particular time, it can be monitored. Energy management. Energy nowadays is a very sensitive area where the batteries are playing role. So this management also can be done. Infrastructure management, where big projects in the urban and rural areas like highways, bridges, railway tracks, etc., can be in these areas also can the IoT can be very well used. Ah. We are coming to the end of the explanation, where IoT system, in brief I shall introduce. IoT system is consisting of three main important blocks. The first heart of the system is IoT device. IoT device is the one which is nothing but a microcontroller or a microprocessor which is customized, made user friendly. The namely Arduino is there, very popular, which is having many versions like you can see Uno, Mega, Nano, and Mini Pro. So these are the versions of Arduino, which is an IoT device. Then comes a little bit complex and more powerful, that is Raspberry Pi, which is a SBC, that is single board computer. And Keel is there, then Bolt is there, Cisco is there, then ESP8286 is with Wi-Fi. These are the IoT devices which are nothing but the heart of the IoT system. Then the input block is nothing but the sensor. For example, the sensors can measure temperature, humidity, flow of water, flow of gas, any kind of flow, pressure, magnetic field, position, location, motion, whether the thing is moving or not, pH value, which decides the acidic and basic nature of the liquid, color, vertical orientation or any kind of orientation, then the light, whether the light is there or darkness is there, then infrared radiation. So and many things which cannot be listed over here, and the list never ends actually. There are more than 30,000 sensors are there in the world. Okay, then the last block, that is where the output is grabbed or used to process the system. The LED and LCD display is one of the example of the actuator. The relays, which are nothing but electromagnetic in nature, they are the actuators. Then motors can be controlled in the agricultural domain. Then linear actuator, something moving in a straight line, that is known as a linear actuator. So these kind of the things are actuator. So input IoT device, then the output. So this is the block diagram of a simple IoT system. And IoT can be, coming to the end, IoT can be clubbed with the artificial intelligence, machine learning, deep learning. The simple block diagram I am showing you so that you are inspired and encouraged. For example, smart home will be having the what you can say, sensor to the right side. You can see the motion, light, contact, and RFID can be sensed. Okay, and they can be stored in a data set, database management system, and AI is incorporated so that the actuators, the outputs can be can handle the lights, electricity, speakers, and lockers, and that environment will create an environment which is nothing but a smart home. So with this, we shall end up the orientation session for the open elective subject for the other branches, namely Internet of Things, a practical approach. Thank you one and all. Have a nice day.
Good afternoon, everyone. Now I will give the brief orientation regarding Java programming basics. So here, the Java programming basics, it's a 3 credit course basically, and it consists of 50 marks as an internal and 50 marks as an external exam. It's a 202 kind of a course. So here we will be practicing more on the programming part. That is, we will be practicing more of the programs. So why this is because since it's a programming language, and what are the applications of Java? So whenever you go for any of the industries nowadays, the most basic thing is Java. You will have a working on a Java testing, and based on many of the things, most of the people, if you take the IT sector and other sectors, any of the things in the programming kind of a thing, if you take the percentage of the people who are working on Java, it's around 30 to 40%. So it's a basic thing here. Next, course learning objectives in this subject. To understand the fundamentals of object-oriented programming in Java. Java is a completely object-oriented programming language. So C is also there. So basically, you have learned the C. In the C, it's a kind of a, it's not completely object-oriented programming. So Java is completely object-oriented programming. So everything is in Java is an objects. So next is to introduce the concepts of methods and classes in Java. So what are the methods and what are the classes? To demonstrate the applications of inheritance. So once the class is defined, again we can use the same class with the different things. So that's what we call as an inheritance. So next is to understand the concept of package and interfaces. These are our course learning objects. So next, prerequisites. What are the prerequisites for this? Basic programming concepts. So if you have learned some basic things, that is enough for learning the Java. It's not like much of the things. Basics of some C programming, some syntaxes, some basic things. Next, in our syllabus, in Unit 1, so Java programming fundamentals we will be learning. So what is a Java language? So what is the difference between our C language and a Java language, and why we need to learn the Java language? Next, the key attributes of a object-oriented programming. Like attributes means it is a secured. Why, how it is will be a secured compared to other programming languages. Why it is most widely used programming language. Next, encapsulation. So encapsulation means here we will be holding the data and functions together into a single unit, so that whatever is there, it will be into a safer unit. Polymorphism, so ability to use the more than one form. Next, inheritance. So some class and functions are defined. Again, we can use the same thing here. We cannot again rewrite the same again once again, and we need to use it. So by using the concept of inheritance, the functions which are already defined, we can modify and use them. Next, the Java development kit. So how we will be using it? Some sample programs. So next, introducing data types and operators. Java's primitive data types, that is basic data types, literals. Next, variables, the scope of the variables and operators. So what are the operators? How we will be using those operators in our Java programming language. Next, in our Unit 2, we will have a program control statements. So here, input characters from the keyboard. So if we enter something, so how to scan it and how to use it. Scanners functions we will be using, we will be learning that. So in C, we will be using scanf. Here, we will be using the scanner function. Some scanner functions will come, so we will be using that. The if statement. So how we will be utilizing the if statement in a Java programming language. Next, nested ifs, the if else add ladder, the switch statements, how we can use the switch statements, nested switch statement, the for loop, the enhanced for loop, the while loop. So all the basic things, whatever we have used in C programming, so how we can modify the same into our Java program, how we can use all those things, how we can use the syntax for if, what is the syntax for while loop, what is the syntax for switch, how we can use it. So those things we will be learning in our Unit 2. So when we go for the Unit 3, here we will have a much above part, that is introducing classes and objects. So here in Java, whatever we learn, everything comes under the classes. So here in C, we will write a main, void main, like that. So here in Java, even main comes under the classes. So everything comes inside the classes. So we will be learning classes and objects here. Class fundamentals, how to create a class, how to create an object. So when we create the object, how we can access those objects in the same class, or how we can access in the different class, and how to create a methods, how to use the functions, and functions defined in one class, how we can use it in another class. So those all basic things we will be learning in the introducing in the classes. Next, deduction of classes and methods. Some of the methods controlling access to class members. So here we will be learning the access specified, private, protected, and public. So if if it is defined as private, then whether we can access in those methods and functions in other class or not. If it is defined as public, then whether we can access. So all these access specifiers we will be learning. Passing objects as a methods. So we have created the objects. So whether we can pass the objects as a methods. If we can pass, then what is the methods? Then how arguments are passed? all these things, method overloading, functions with the same name in but a different return types. So all these things we will be seeing some of the programs, basic programs, along with these basic things. Next, inheritance. So inheritance means so some functions and methods are defined. I want to use them, but I don't want to define them again. So how we can use it? That comes under the inheritance. Inherit. So inheritance basics, member access and inheritance, constructors. So constructors comes means here functions and methods have the same name here. So some class having the ABC method name, class name, and even the method also having the same name. That's what we call as a constructor. What is the use of a constructor? So if we use the constructor, whether how we can create the objects, so what we can initialize, all those things we will be learning here. Next, using super, multi-level hierarchy. So one level, next level, and after that level. So multi-levels hierarchy, some basic things. When are constructors executed? Superclass reference, subclass methods, method overriding. So what is overriding? So we have seen in unit 3 method overloading. Here we will have a overriding. What is the difference between that? When we have to use the overloading and when we have to use the overriding. Polymorphism. Next, using abstract classes, using final and the object class. This is what some basic things we will be learning in our unit 4. And in our unit 5, we have interface fundamentals. So interface is one part. So what are the fundamentals of an interface? How to create any interface and how to implement it when we have used it. So next, one interface we can create it, whether we can create more than one, that is multiple interfaces. If we create it, how we can implement the multiple interfaces. So all these basic things we will be learning in a interfaces part. Next is the packages. So what is a package means? If something is defined, I want to access it. So how we can use it? So import is used for accessing any of the packages. Even we can create our own packages. So some of the methods we know, some of the things we can create it and store it. Later on we can use our own packages, custom packages, that also we can do it. So those how to create a custom package and use the custom package and how to use the inbuilt packages, all these things comes under the packages. So next, textbooks, these are the reference and these are not limited to only this part. We can refer anything, many of the books and things are there. So some of the textbooks and reference are Herbert Shield and Dale Scarin. This is one textbook and reference book is this one. Course outcomes, at the end of the course, you will be learning what are the classes and methods, Java application programs, we will be learning inheritance concepts, interfaces, these things we will be learning. And open-ended programs. These open-ended programs are based on our syllabus. So first year is write a Java program to demonstrate the implementation of two-dimensional array. How we can create a two-dimensional array and how we can use it. Next, write a program to demonstrate the implementation of class and its member methods. So how to create a class and how to create a methods inside a class and how we can access it. This comes under our second program. Third one is write a program to demonstrate the implementation of parameterized method and constructor. Here parameterized refer to functions having some parameters. For example, void ABC, inside the bracket int a, int b. These are the parameters. So how to demonstrate that, how to use it, parameterized methods and constructors. So this comes under our term of number 3. And fourth is write a program to demonstrate the implementation of inheritance. So one class we can create it and how to use it using the inheritance. Next, write a program to demonstrate the implementation of method overloading and method overriding. Both part we will be doing here. Next is interface, demonstrate the implementation of. Next is the packages, customized exception handling, string handling, and Java Sphinx. Sphinx is another different part. This is for creating the graphical user interface. So this is one separate part. This we will be learning in our this application, Java application kind of a program. So this we will be learning in our open-ended experiments. So once we have done with this, so this is your split up part. CI split up is IA test, that is 30 marks, and journal is 20, total is 50 marks. Next, again SWE, this is the split up. So this is what regarding our Java programming basics. Thank you.